Inshallah, students, in this class, we are going to continue the questions based on Green's theorem. In the previous class, we already done two questions based on the Green's theorem. Those who have not seen that part, I request them first to observe that, to see that, because we already gone in detail in that class about the two questions. Now, inshallah, we are going to continue one more question. Verify Green's theorem for. Verify means we have to do both in both the methods. First, we have to find the line integration, then the surface integration. You see here, what is the formula of this Green's theorem? Line integration m dx plus n dy. Line integration m dx plus n dy equals to surface integration or double integration dou n by dou x minus dou m by dou y dx dy. This is the Green's theorem. Once more you watch, what is the Green's theorem? Integration of m dx plus integration of n dy equals to surface integration or double integration dou n by dou x minus dou m by dou y dx dy. But we have to find what is the region actually. Through the region here and curve here, let me see what is the region here. We have to see this y equals to root x and y equals to root x comma y equals to x square. You see, we already seen in the previous classes, in the your previous classes, you know what is y equals to x square. See here, y equals to x square is this curve upwards. This curve is called y equals to x square. This is the parabola which you already studied in the 12th class. Y equals to x square. Now, if you square this one, this will be like this: y square equals to x. Y square equals to x. This is also parabola on the right side. This is also parabola right side. But this is, we are taking only root now, so we don't take this one. Okay. So this is the curve, closed curve. Let me write this O, A, B, C. So we have to go once into anti-clockwise OAB, one integration along the line OAB curve, then along the line BCO, along the curve BCO. But we have to know these points of intersections. This is by looking itself we can say this is origin, but we have to solve for B. So let me solve this to get this point. If you solve these equations, we are going to get the point of intersection. What is here? Y equals to x, y equals to x, sorry, x squared. Therefore, compare this one, root x equals to x squared. To remove this squaring both sides, this root will become x, this x square becomes square whole square x power 4. Bring this x here, x power 4 minus x equals to 0. Take x common, x cube minus 1 equals to 0. Separate this one, x equals to 0, x cube equals to 1. That is x equals to 0, x equals to 1. Now watch carefully. If we substitute x equals to 1, we'll get y equals to 1. If we substitute here 1, root 1 is 1, so y equals to 1. Sorry, if first substitute x equals to 0, y equals to 0. X equals to 1, y equals to 1. Therefore, we are having 2 points. Let me denote this by origin 0, comma 0. And we are denoting this by B. So B is 1, comma 1. So we got this 0, comma 0. This is 1, comma 0. So let me start with the curve along the curve OA, along the curve OAB. Along the curve OAB. Now see here, first thing, what is the equation of this curve? Y equals to x square. Y equals to x square. Y equals to x square. Now second thing, this equation is, what is this? Y equals to root x. So let me solve along y equals to x square. Along the curve will be y equals to x square is the curve equation. Now you differentiate this, dy will be x square is 2x dx. Differentiation of y is dy, x square is 2x dx. Now what are limits of x? X equals to 0 to x equals to 1. X equals to 0 to x equals to 1. So this is the next step. Now let me solve this one. You see here, I am continuing this one. Now let me write once more the question. What is question we are having? Integration of curve integration, line integration 3x square minus 8y square dx plus 4y minus 6xy dy. So let me change this one. In place of y, we write x square. In place of dy, we write 2x dx. See here, and the limits of x are x equals to 0 to 1. x equals to 0 to 1. We are changing complete equation in terms of y. Sorry, in terms of x. We are taking out y from we are taking y from here, dy from here. So the complete equation will be in x. So we write the limits as x equals to 0 to 1. 3x square minus 8. In place of y, if we keep x square, whole square will be x power 4 dx, plus 4 into y is x square, minus 6 into x into y is x square. So x square into x will be x cube dy. Now what is dy? We are having 2x dx. Now let me take dx common here. Integration x equals to 0 to 1. If we take dx common here, what is left here? 3x square minus 8x power 4. Now multiply this one, plus 4 to the 8. Plus 4 to the 8. Once more, let me see the question. This is 3x square minus 8x plus, yeah. Now see here, I have verified the question is right or wrong. So here, you see here, you multiply 4 to the 8 plus 8 x square into x cube. Once more, you see here, 4 to the 8 x square into x cube minus 6 to the 12 x cube into x power 4 dx. Once more, you see here, 3x square minus 8x power 4, 4 to the 8 x square into x cube minus 6 to the 12 x cube into x power 4. Now let me add the similar terms. Let me add the similar terms. Now see here, integration x equals to 0 to 1. If you add similar terms, see here, 3x square is only 1, we are having 3x square, minus 8 minus 12 will be minus 20x power 4. Then what is left here? Plus 8x cube dx. Now let me integrate this one. Integration of x square is x cube by 3, x power n plus 1 by n plus 1, minus 20. Integration of x power 4, x power n plus 1 by n plus 1, 4 plus 1 5, plus 8. Integration of x cube is x power 4 by 4, 0 to 1. Let me cancel this one. 3 3 cancel, 4 ones are 4 twos are 4, 5 ones are 5 fours are. If you substitute the upper limit, what we will get? In place of x, 1, upper limit is 1, minus 4 ones are 4, plus 2 ones are 2. So what is the value here? The value we are going to get from this is minus 1. See here, lower limit is 0, so it will be 0. 2 plus 1 3, 3 minus 1 is minus 3, 4 minus. So we got one value, and then again we have to, let me write this here. I'm writing this here, watch carefully. So along this curve, along OAB, we got the integration as minus 1. We got the integration as minus 1. So let me solve the next case. Now see here, we solve this one. OAB, we got the integration as minus 1. Now we have to go along BCO. Let me write like this, along BCO. BCO. What is the equation of the curve? Y equals to root x. Now let me differentiate. Differentiation of y is dy, equals to differentiation of root x is 1 by 2 root x dx. 1 by 2 root x dx. Once more, you see here, y equals to root x. Differentiate this one, dy equals to 1 by 2 root x dx. One more thing is left. What is left here? See here. Well, now let me see the values of x. Here x equals to 1, here x equals to 0. Therefore, x equals to 1 to x equals to 0. So let me change this one. Integration of x equals to 1 to 0. 3x square minus 8 into y square. 8 into y square. So value of y is root x. So whole square dx, plus 3x square minus 8 into y is root x whole square, plus 4 into y is root x, minus 6x into y is root x dy. dy is 1 by 2 root x dx. 1 by 2 root x dx. So let me continue this one. Now see here, equals to integration x equals to 1 to 0. This root square will get cancelled, 8x. This will become 3x square minus 8x. Now watch carefully. If you take common from this 2, what we will get common? We will get 2 root x common. We get 2 root x common from here. What is left here? 2 minus 3x into 1 by 2 root x dx. 1 by 2 root x dx. This 2 root x will get cancelled. So what is left here? Plus 2 minus 3x dx. Okay, once more you see here. If we take 2 root x common here, what is left here? 2 minus 3x into 1 by 2. This 2 root x will get cancelled. What is left here? 2 minus 3x whole dx. Let me take. So let me add this 2, then we integrate. Let me first add the similar terms. Integration x equals to 0 to 1, 3x square minus 8x minus 3x is minus 11x plus 2. Now integration of x square is x cubed by 3 minus 11. Integration of x is x square by 2. Integration of 2 will be 2x. Integration of 2 will be, sorry, x equals to 1 to 0. This is x equals to 1 to 0. Integration of x square is x cubed by 3. Integration of x is x squared by 2. Integration of 2 is constant, 2x. This 3 will get cancelled. So if you substitute upper limit, it will be 0. Upper limit 0 means 0, 0, 0, 0. Minus lower limit means 1. So this will become 1 minus 11 by 2 plus 2. So 0 minus, you add this one, 2 plus 1, 3. If you take LCM, 2 3s are 6 minus 11 plus 6 by 2. This will become minus 5 minus 1 is plus 5 by 2 plus 5 by 2 plus 5 by 2. So we got the next value. Therefore, see here, I will show you. So this we got as 5 by 2. 5 by 2. So therefore let me add now. So what we'll get answer, we have to add this to. See here, therefore this integration will become equals to the first value we got minus 1 plus the second curve value we got 5 by 2. So 2 ones are 2 minus 2 plus 5, 3 by 2. So the left hand side we got here. We have solved using the line integration. Now we have to go for the surface integration. Just now we have solved by line integration. Now we will go for surface integration. So what is surface integration? First we have to compare this with m. This is n. Integration of m dx plus n dy. So now we are going to solve by another method. M equals to 3x square minus 8y square and n equals to 4y minus 6xy. We have to find dou m by dou y. So with respect to y, we don't have y here 0. Y square is 2y, 2 is 16y. Now dou n by dou x. With respect to x, we don't have x here. d by dx of x is 1, so this will be minus 6y. This is the first step. Second step you see here about the limits. Watch carefully. You take x limits as constants. What are the constants here? X equals to 0 to 1. X equals to 0 to 1. So x equals to 0 to x equals to 1. X equals to 1. Whereas we have to take y in terms of x. Y in terms of x. So what is here lower limit? First we have to go like this from here to here. Y equals to x squared to y equals to root x. So we have to solve like this. Let's see here. Let me start now. Now we have what we are going to have double integration of dou n by dou x minus dou m by dou y dx dy. Watch carefully. First you write constants. What are the constants? X equals to 0 to 1. Always take x constant, better. Then let me take in terms of y. Y equals to x square to root x dou n by dou y minus dou n by dou x. Let me solve this separately. See here. What is dou n by dou x minus dou m by dou y equals to dou n by dou x is minus 6x. Watch carefully. Dou n by dou x is minus 6x minus 6y. Sorry, minus 16y minus 1 is plus 16y. So this is 10y. So dou n by dou x minus dou m by dou y, this one we can write as 10y dy. Then close the bracket, then write dx. Now first let me integrate with respect to y. Integration of y is y square by 2. Integration of y is y square by 2. We write like this x as it is, x equals to 0 to 1. I'm writing 10 outside because this is constant, we can draw it outside. Now integration of y is y square by 2. What are the limits here? X equal x square to root x. dx. 2 ones are 2 5s equals to integration x equals to 0 to 1 5. Upper limit means in place of x y you have to write root x. In place of y you have to write like root x. So this will be root x whole square minus lower limit means x square in place of x y x square whole square dx. Now let me continue this one. Find to integration 0 to 1. Root square will get cancelled with x. X square whole square x power 4 dx. Now find. Let me integrate now. Integration of x is x square by 2. As integration of x power 4 is x power 5 by 5. What are the limits here? 0 to 1. Now upper limit minus lower limit. Upper limit minus lower limit. So let me write upper limit 1 by 2 minus 1 by 5. You take LCM. LCM is 10. 5 will come here. 5 minus 2. 5 ones are 5 twos are. So what is left here? 3 by 2. Note this as 2. See here. By line integration, we got the answer 3 by 2. And by surface integration, we got the value 3 by 2. Therefore, 1 from 1 and 2, we write lastly. Green's theorem is verified. Green's theorem is verified. Now see the next question. Till now we have done 3 questions on verifying the Green's theorem. But in this question, watch here, using Green's theorem, we do not have to verify, okay? Evaluate using Green's theorem. When the question is to evaluate using Green's theorem, then we use for line integration, we solve by using surface integral. Surface integral or area on double integration. This curve integration will be difficult, whereas solving this is easier. So when the question is given using solve means we have to find the line integral using surface integral. We have to find the line integral using surface integration. So see here we are having line integral, but you're going to solve using this one. So let me first write the Green's theorem. Next one, let me compare this m dx plus n dy. So we are having the value of m is y minus sine x. What we required here, dou m by dou y. Therefore, differentiate with respect to y, dou m by dou y. D by dy of y will be 1. We don't have y here 0. Now this is n equals to cos x. N equals to cos x. So we want dou n by dou x. So d by dx of cos x is minus sine x. D by dx of cos x is minus sine x. Next thing is we have to see the lines. What are the things here given? 3 lines are given. Y equals to 0, x equals to pi by 2, and pi y equals to 2x. Now watch here what we can have this one. Now let me draw the triangle here. See, this is a triangle. I'll explain you. Suppose this is the coordinate axis. Now y equals to 0 means x-axis. Y equals to 0 means x-axis. Next thing is x equals to pi by 2. This line, suppose the x value here is pi by 2. So this line is called x equals to pi by 2. X equals to pi by 2 is this line. Now what is next here? Pi y equals to 2x. Bring this pi here. Y equals to 2x by pi. It is of the form y equals to mx. So this line passes through origin. This line passes through origin. Suppose this is the line y equals to 2x by pi. 2x by pi. So this is the triangle. We have to go for this triangle. Let me denote this one as 0, then A, then B. Now see here, origin is O, A, B. Now this point A, we can write this as pi by 2 comma 0. This point is x coordinate is pi by 2. X coordinate is pi by 2. Okay. If we required we see for y or y, we can write 2x means 2 into pi by 2 by 2. 2 will get cancelled. I think this is 1. Okay. If you keep y equals to 2x by pi, in place of x if you write pi by 2, in place of x by 2, 2 into pi by 2 into x. In place of x if you write pi by 2, this will become 2 into pi by 2 by pi. This will get cancelled. I think this value is 1. Let me see this. Okay. Now see here. So this is the triangle we got here. So we have to go, sorry, we have to take the limits of x and y. Just now I explained, always take the limit of x in terms of constant. So here x is 0, here x is pi by 2. So for x, we take x equals to pi by 2. Sorry, x equals to 0 to x equals to pi by 2. X equals to 0 to x equals to pi by 2. Now we take x equals to 0 to x equals to pi by 2. Whereas watch here, how to take y. You see here, suppose I am drawing one line. Y will go from here to here. This is y coordinates. 0 to the line. Wherever you go, 0 to the line. Y from here to here, from here to here, from here to here. Here is the value of y will be here. Sorry, here this is y equals to 0. So this equation, x-axis equation is y equals to 0 to y equals to this line. This line is 2x by pi. So let me solve this one. I'm writing once more the question. See here. What is the question we are having? Uh, we have to solve this by double integration dou n by dou x minus dou m by dou y dx dy. First, you write the limits of x. X equals to 0 to pi by 2. Now you write the limits of y. Y equals to 0 to y equals to 2x by pi. 2x by pi. Okay. Dou n by dou x. Dou n by dou x is minus sin x minus dou m by dou y. Dou m by dou y is 1. Dou n by dou x minus dou m by dou y dy. First we are integrating with respect to y, right? Dy, then dx. Then now we have to integrate with respect to y. See here, watch carefully. Integration x equals to 0 to pi by 2. Let me do one thing. I'm taking minus common from here. If you take out minus outside, this will become plus. If you take out minus common, this will become plus. Now let me integrate with respect to y. We don't have y here. We have to integrate with respect to y. So we must suppose here 1. Integration of 1 will be y. Integration of 1 will be y. So this will become y sin x. Plus integration of 1 will become y. 0 to 2x. 2x by pi dx. Now upper limit minus lower limit. See here, equals to minus integration x equals to 0 to pi by 2. 0 to pi by 2 y. In place of y, you have to write 2x by pi sin x plus y means 2x by pi dx. Now upper limit is, sorry, lower limit is 0. See, this will become 0. One more thing you see here. You take common here, 2 by pi, 2 by 2 pi by pi. I have taken outside. What is left here? X equals to 0 to pi by 2. Now what is left here? X sin x minus x. X sin x minus x. We can take x also common. If you take x common here, what is left here? It is left with sin x plus 1. Sin x plus 1. Okay. Let me continue from the starting of the board. Now see here, this is multiplication. This we say integration by parts. We are having two methods. One is in the previous classes you read f of x into g of x islet method. Okay. One more method is we can use like this. Integration of uv is u v1 minus u dash v2. In later inshallah in the next classes inshallah you will go in detail about this formula in the next year inshallah. Now I am showing short. We have to use this formula. This is u, this is v, to integrate by integration by parts. Or if you know this formula, you can use f of x into integration of g of x minus 4 integration. This is v sin x plus 1. Now you have to differentiate this. Differentiation of u is u dash. D by dx of x is 1. Now we have to find v1 v2. V1 means integration. V1 means integration. So integration of sin x will be cos x. Integration of sin x will be minus cos x. Integration of sin x is minus cos x plus integration of 1 is x. But again we have to differentiate because we have to go, sorry, integrate. We have to go up to v2. V2 means again integration. So v1 integration is v2 minus integration of cos x is sin x plus integration of x is x squared by 2. So we have to integrate using this formula. This is minus 2 by pi. Now what is this here? U v1. U is x into v1 is minus cos x plus x. U v1. U v1 minus u dash. U dash is 1 into v2 into v2. v2 is minus sine x plus x square by 2. Limits are 0 to pi by 2. Now upper limit minus lower limit. Limits are 0 to pi by 2. Let me solve this one. See here, minus 2 by pi x here, if you substitute, what is the value of x is pi by 2. X is pi by 2 into cos 90 is 0. Cos pi by 2 is 0. Leave this one. What is left here? Pi by 2. X is pi by 2. Once more here, upper limit. Upper limit means in place of x pi by 2. In place of x pi by 2. Cos pi by 2 is 0. Again x is pi by 2. See here, minus into minus plus, minus into minus plus sine pi by 2. Sine 90 is 1. Sine 90 is 1 plus x square means pi square by 4. Again we are having 2 here. This is upper limit. If you keep lower limit here, it will be 0. Sine 0 is 0, 0. So lower limit is 0, leave this one. So what is left here? Just we have to solve for 2-3 steps here. So here there is a slight mistake here. Minus into minus plus. Minus into plus minus. So let me complete this one. Minus 2 by pi into. This is here, just I will do in the rough work. This is pi square by 4 minus this is pi square by 8. If you take LCM here, 8, 2 pi square minus pi square will be pi square. So this will be pi square by 8 plus 1. You do one thing, you keep minus as it is, you multiply this to pi by 2 by pi into pi square by 8 plus 2 by pi into 1. What we did, minus as it is right here, multiply this to this two. So last term, pi and square will get cancelled, 2 ones are 2 fours. So what is left here? Minus of pi by 4 plus 2 by pi. So what does we learn here? When the question is using Green's theorem, then we have to find the line integration using surface integral. Using surface integral. See one more. This is also one important question, because the time already is much more. If we do this detailed, the video will be so lengthy. I'm explaining this in shortly. See here, you have to find using Green's theorem. What we have to do using Green's theorem is we have to solve this one using surface integral. So first see the one after one. What is this? Y equals to x square, y square equals to x. We already know, just done the first question. These are the two parabolas. We have to solve for this. This is origin. To get this one, let me solve this one. Let's see how I solve this one. Y equals to x square, y square equals to x. So substitute these two equal. So in place of y, if we keep x square whole power x power 4 minus x, we already done this we will get the point 0 comma 0 and 1 comma 1. Next thing is we have to find, compare this one. This is m, this is n. Dou m by dou y is integration with respect to y is 1 into 2x 2x. With respect to y, this is constant 0. Dou n by dou x square is 2x constant 0. So this we got 2x, this we got 2x. So the next thing is we have to take x in terms of constants. X equals to 0 to x equals to 1. Y in terms of x, y equals to x square to y equals to root x. See here, this equation is y equals to x square to y equals to root x. So next one we have to solve this one now. Let me find this separately. Dou n by dou x minus dou n by dou y. Dou n by dou x minus dou n by dou y is 2x minus 2x, that is 0. So this will become 0. Integration of 0 will be 0. 0 integration of 0 will be 0. This is the short I explained you. So inshallah in the next class we are going to continue this one. I request to the students to like this, subscribe and share this channel. Inshallah we are going to continue in the next class.